NASA has given critical insights. Pluto isn't what we think. What is NASA proposing? Are they analyzing the most recent discoveries from the New Horizons space probe, which uncover that odd things are occurring on Pluto's surface? One of the striking pictures, in fact, shows an object that seems to drift across Pluto's surface. This raises unsettling questions regarding whether some type of advanced alien life exists on this distant world, or if we are dealing with an unusual geological feature. Pluto may be small, but the stories it has to tell are epic and full of surprises. When Pluto's planetary status was revoked in 2006, scientists were unaware of the data from the New Horizons probe, which came only a few years later. Since then, we've come to understand that there is more to this little celestial body than initially thought. How did astronomers decide to downgrade this planet, which many of us grew up knowing? The decision to reclassify it as a dwarf planet came after the discovery of numerous other small planets in the Kuiper belt. Researchers felt it was necessary to establish a distinction between what constitutes a planet and what is a smaller body, like a trans-Neptunian object. Pluto scores points for its size and round shape, but it shares its orbit with several other objects, so its path isn't considered clear. This was the justification for Pluto's removal from the list of major planets in the solar system. Many people on Earth found this decision disheartening. The renaming caused disappointment among the public. Pluto, no longer a planet, was a troubling concept for many. The fact that this peculiar little planet had such a devoted fan base even led to letters of protest being sent to NASA, with prominent scientists advocating for Pluto's reinstatement. Government organizations also received letters from frustrated citizens demanding Pluto's planetary status be restored. Since its discovery in the 1930s, Pluto had been a critical part of the narrative of the 9 planets, a fixed fact in the minds of many. In 2015, when New Horizons sent back the first clear images of Pluto, we finally saw its fascinating surface. Imagine it was the first real image of Pluto. The depictions we'd seen before, whether in textbooks or on diagrams, were artistic interpretations, not actual photographs. Pluto had even evaded the Hubble telescope's gaze. Yet New Horizons captured this small world as it truly is. Magnificent, intricately detailed, and with a heart-shaped feature that won over millions. Since then, Pluto, at the edge of the solar system, has gained even more fans. Perhaps one day, astronomers will reconsider, and Pluto will regain its status as a planet. The first genuine pictures of Pluto left everyone in awe. It was a remarkable moment when the initial data from New Horizons reached Mission Control in 2015. Everyone present recognized they were about to see a planet for the first time, one that everyone knew of but had never seen up close. The computers on Earth pieced together this stunning image from countless bits of data and pixels. What the probe revealed about Pluto changed our understanding of this distant world. Pluto is far more complex, dynamic, and alive than planetary scientists ever guessed. This little planet is covered in fascinating features and puzzling geological phenomena that no one had anticipated. Every new picture sent back by New Horizons transformed Pluto from a distant, icy mystery into a rich and dynamic world. Far from the cold, cratered wasteland many had imagined, Pluto revealed brilliant patches of ice, deep canyons, and smooth frozen plains. It took years for the vast amounts of data, images, and discoveries to travel from Pluto to Earth. Since 2015, we've been captivated each year by new, intriguing insights about this tiny planet. But who or what is that moving on Pluto's surface? This perplexing image made headlines in 2016. What could it possibly be? It appears to show a figure walking across an unusual honeycomb-shaped snowfield. What's happening are ice formations. However, unlike Earth's ice, Pluto's frozen surfaces are composed of nitrogen and methane. Researchers identified the mysterious object as a massive chunk of ice seemingly drifting across the frozen plains. This huge block of ice is believed to be solid nitrogen. These unusual landforms revealed something remarkable to scientists. There appears to be a nitrogen reservoir a few kilometers beneath Pluto's surface, where solid blocks of ice form. Geological forces within Pluto push these blocks upwards, creating the honeycomb-like patterns and fields, as well as the wandering mountains. This discovery suggests a warm core within Pluto, providing evidence that could have significant implications for how we understand the dwarf planet. Pluto is far more dynamic than previously thought. Heat-driven land development, combined with changes in surface features, hints at a kind of aliveness that we've underestimated. This little world shows a surprising level of activity and complexity within it, which strongly suggests that there are pockets of liquid inside Pluto resembling seas or magma. William McKinnon, a geophysicist on the New Horizons mission, even compared the planet's internal structure to a strikingly large feature, like Hudson Bay in Canada. Computational insights showed that this remarkable landscape developed over millions of years and remains incredibly dynamic today. Can you spot the exact location beneath the icy mass? This feature was likely created by sublimation, a process in which a substance transitions directly from a solid to a gaseous state, bypassing the liquid phase. These processes occur due to Pluto's extreme temperatures, complex geological activity, and atmospheric properties. A once-thought dead world, Pluto continues to astonish. In the snow on Pluto. Does that sound insane to you? Competently, it's a reality. Pluto genuinely is a secret. The New Horizons mission uncovered fascinating aspects of the atmosphere and changes on this planet. Pluto, which orbits in the far-off areas of the Kuiper Belt, experiences dramatic seasonal variations due to its eccentric orbit and tilt. The New Horizons spacecraft found that Pluto's atmosphere, a thin layer of nitrogen, methane, and carbon monoxide, changes significantly depending on how close or far Pluto is from the Sun. These changes impact the atmosphere and surface conditions of the dwarf planet. One particularly fascinating aspect of Pluto's weather is snow. On Pluto, this includes mostly frozen nitrogen and methane. Unlike Earth, where snow forms solely from water, the extraordinarily low temperatures on Pluto cause these more volatile gases, nitrogen and methane, to condense and fall as unique snow. These interactions shape and support Pluto's surface by covering the landscape with fresh deposits. The disturbances, in turn, drive other geological cycles like frozen movement and possibly cryovolcanic processes. The New Horizons team also showed that these seasonal cycles are closely tied to atmospheric pressure. When Pluto is closest to the Sun, the weak sunlight is enough to warm the dwarf planet's atmosphere, causing it to expand slightly. As Pluto moves farther from the Sun, the atmosphere freezes and sinks back to the surface. This leads to a remarkable phenomenon. When Pluto's atmosphere condenses, it can literally snow nitrogen and methane. The variations in surface brightness and the distribution of icy deposits further suggest that nearly all surface features on Pluto are connected to these atmospheric cycles. Since Pluto's mountains are not made of rock but of ice, which is much more malleable in this world, the entire surface shifts significantly more than that of Earth. For example, what does Pluto's heart include? Who would have thought that Pluto's heart isn't just a fantastic thermal scar? Despite its striking appearance, this region is also one of the most astonishing areas on Pluto. Once called Sputnik Planitia, this region is named after the first artificial satellite, Sputnik 1, launched by the Soviet Union in 1957. This massive heart-shaped ice surface stretches over an area of around 1,000 kilometers and is composed primarily of nitrogen ice with traces of frozen methane and carbon monoxide. The bright, nearly flawless surface of Sputnik Planitia forms a sharp contrast to the darker, more complex regions around it. Geographically, Sputnik Planitia is a large impact structure that was likely later modified by volcanic processes. Unlike traditional volcanic activity on Earth, where magma rises from the planet's interior, cryovolcanism on Pluto involves cold materials rising from the dwarf planet's interior to the surface. Heat sources deep within Pluto cause nitrogen and other volatile substances to warm and push to the surface, where they freeze and form unique features like this one. Sputnik Planitia is surprisingly flat, which leads scientists to believe that the frozen surface is continuously renewed by internal processes. It's possible that convection processes within the ice sheet shape these features. Scientists believe there may be a layer of liquid water beneath the smooth ice sheet of Sputnik Planitia, kept liquid by heat inside Pluto. While researchers are unsure whether life could exist in this subglacial ocean, it's not entirely inconceivable. What role does Charon play? Few knew before the New Horizons mission that Pluto has its own moon, not just one. Charon, Pluto's largest moon, was discovered in 1978 by the American astronomer James Christie. Charon is remarkably large compared to Pluto, with a diameter roughly half that of the dwarf planet, leading to a unique relationship between the two. They are tidally locked, meaning Pluto and Charon always show the same face to each other. Charon's surface is also strikingly different from Pluto's, with massive canyons and large impact craters. Scientists believe that Pluto and Charon have been exchanging material as comet-like objects. While Pluto's surface is a frozen wonderland of nitrogen and methane, researchers suspect much more is happening beneath the icy crust. As New Horizons revealed, Pluto's interior may be far more dynamic than once suspected. The presence of heat-driven geological activity suggests that the dwarf planet could harbor a subsurface ocean, or at least pockets of liquid water kept warm by internal processes like tidal heating or radioactive decay. This possibility, along with the detection of complex organic molecules also found in the atmosphere, raises the question: could there be potential for life on Pluto, even in such extreme conditions? While it's unlikely that life as we know it could exist on Pluto's surface, the idea that some form of microbial life could survive beneath the icy shell isn't entirely unfathomable.